Hello, let's continue our advanced Sudoku series with Leaps and Bounds by Jovial. This is puzzle number 3 of chapter 3 of the Sudokult Gospel document, which you can find a link to in the description. And of course, you can also find a link in the description directly to this puzzle if you'd like to try it yourself. And and as always, I do know what technique I'm looking for. I just don't know where it is in this particular puzzle, but I do know what it is and how to explain it. And so, I'm going to get started right now. I mean, it's tempting to just pencil this middle row, isn't it? What do we need? We need a 1, 5, 7, 9. Okay, 7's in one of these two. I'll use red for that. And 5, oh, this is a 7-5 hidden pair is what this is. So I don't even need the red. And then here we have a 1 and a 9, which are not resolved. Okay. All right, what are we doing up here? We have a bunch of 3s. We have 2 2s looking into here. So 2's in one of these two. Let's see. What else do we have here? Need a 2 and a 4 in this column. Is that helpful? 4, 4. Not really. Oh, I guess I do have 2 2s looking into here, but it's in 3 places. I don't really mark that. All right, let's look at this band here. We have all the 6s, 2 7s look into here, but there's no 7s to cross it. What else is going on here? Not much, huh? Let's look over here. 2s are done. 3s look into here. So we have a 3 in one of these two. Not 4, 3. 1 looks in and 1 looks in. So 1's in one of these two. 2, 3. Oh, did I look at the 2 3s already? I did. This one looks up here. This one looks in here. So there's a 1 in one of these two. Anything else vertically here? There really isn't much to find, is there? 2 6s look down. So there's a 6 in one of these two. How about over here? 2 4s and this 4. So 4 is one of these two. We got the 9s. 2, 4. Okay. Over here, we do have 2 3s, but that's not good enough. Actually, this is a pair, and I should have filled that. Oh my gosh, I should have filled that. This is 2 3, right? So actually, the 3's looking into here. This 2 3 pair sees here. So 3's in one of these two. And the same, we have 2 3s here and these 2 3 pairs. So 3's in one of these two. What about 2s? Yeah, 2 ends up in one of these two. And then, yeah, 2 ends up one of these two. Interesting. I don't know how I just didn't pencil that pair. My apologies there. You're probably yelling about it. But I got there. Let's see. Oh, we have a bunch of 8s looking into this box. So there's an 8 in one of these two. Does it have to do with this row being limited? Like we need a 5. Yeah, 5's in one of these two. How did I miss that the first time? That's been there. The 6s, okay. What about 7? Yeah, we have 2 7s looking in as well. Oh, but 7's somewhere over here. We don't really know where. This isn't 2, 3, 5, 6, 7. I don't think that's good enough. 2, 3, 5, 6, 7. There's still 4 digits left. Okay, what else do we have going on here? Does this 1 9 pair do anything interesting? What about this column? This column's down to 4 digits. We need a 1, 7, 8, 9. This one's not 1 or 9, so this is only 7, 8. I think that's the only restricted one, though. The rest can be 1, 7, 8, 9. This column needs 1, 4, 5, 9. This one's not 5, so this is 1, 4, 9. These two aren't ones. So these are from 4, 5, 9. And I noticed this one can't be 9. So 1 is limited to these two. Let's use gray for that for now. Is 1 limited? 1's limited to these two. Okay. Kind of an interesting, like, pattern for 1s there. We have 1s in one of these two. This already can't be a 1. Okay. Is there... Let's think about 1 some more. Because they are limited in the left and right columns. I mean, I feel like 1 can be in any of these. Or here. In this column... Like, 1s are very much not restricted in these columns. Like, they're here, 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 here. Okay, what about this column? 1 can be here or any of these. Okay. So maybe 1s are not interesting today. Let's pick 9 then. I'm picking digits that are just because I know this is human crafted. I'm picking digits that might have been picked by the setter. Are 9s at all interesting though? There's only 2 9s in the grid. I don't really think that they would be. Okay, what's like super restricted? 2s are super restricted. So we have 2s here, we have 2s here. Let me highlight all the 2s. 2s here and 2s here. So yeah, that's just 2 rectangles left of 2s, so that's not gonna be helpful. Remember 3s being pretty restricted. Let's look at that. 3s. Did I miss anything? What are the... Oh yeah, there's the counterpart. Yeah, so 2 rectangles left of 3s as well. So those are the ones I saw as restricted. Is there something about 4s that's interesting? 4s can be here. In this box, 4s can be here. In this box, 4s can be here. No, not there. Oh, so 4 is limited to 2 places in this box, right here and here. So 4 is there. 4 is here. 4 in this box is not very restricted, is it? Here. This box is all up here, and this box is all up here. No, I don't see anything to do with 4s. 5s, maybe? 5s are here. 5 looks, we just don't have any 5s up here that are of interest. What about over here? 5s are here. And, oh, 5s are limited to these two. I should mark that. Yeah, up here we don't have a whole lot of restriction going on. But not these two. This is where 5s can go. Nothing super interesting about that. I thought maybe this 5-7 pair we found would be helpful. It could be the 7s, I guess. No, I'm not really seeing it. All right, 6s. I'm just going through every digit at this point. 6s are down here. 6s are here. In this box, 6s are like anywhere here. Is this row? Are 6s limited in this row? Yeah, 3 places. No, wait. Hold on, where does 6 go in this row? Here or here? All right, well, let's just put this box in. There we go. And then this box, they go here. Okay, does that help me? Before I talk about it, let me see if it actually helps. I don't think it does. Does it? Oh, it absolutely does. Absolutely does. Okay. So I found, I don't know if this is even the one that I'm supposed to find, but let's start by talking about 6 in this row, which is one of these two. I'll put that in green. And then 6 in this row, which can only go here or here. You can see that it can't go in any of these other. This 6 takes out of there. This 6 takes out of here. This 6 takes out of here. So this row, there are only 2 places. And then in this row, this 6, this 1, this 6, this 6, and then these filled. They're only there. So this is what's called a skyscraper. It's kind of like an X-wing, but it's kind of offset on one end. So one end, the logic is actually fairly simple to talk about for skyscrapers, which is this row needs a 1 and this row needs a 1. And they can't both go in this column. We can't put both of the ones here. So we're definitely going to end up with a 1 here or here. Kind of simpler than a wing, really. It's a single digit pattern that only requires 4 cells. Those 4 cells are always going to be in 4 different boxes. In order to do something useful, they'll be in 4 different boxes, just like an X-wing would be. So again, if this green, oops, I didn't mean to do that. If this green were here, right, this would be an X-wing, where they both line up in 2 columns, but it's offset where these 2 don't line up. So what are the possibilities here? I could have both of these be 1. Hold on, 1 is not the digit, 6. I could have both of these be 6. Or I could have 6s like this, or I could have 6s like this, but what I can't do is have 6s like this, which means every single case has at least 1 6 in these 2 cells. So that forms a strong link between them, if you want the technical terminology. You can also just see this as a very simple alternating inference chain. So let's draw that out. And we're always talking about 6 in this case. So 6 here, there's a strong link between the 6s here, between these cells. There's a weak link between the 6s here, and there's a strong link between the 6s here. So strong, weak, strong, that connects this strong link to this, that connects these 2 together and forms a strong link between these 2. The result is there's a strong link here. So that would be the rigorous thing. But because there is a strong link between them, or if you want to be a little bit more direct, because there's a 6 in one of these 2, there cannot be a 6 here, and there cannot be a 6 here. Because if I were to put a 6, say, right here, then this green cell couldn't have a 6 in it. So in this row, I'd need a 6 here. And this green cell couldn't have a 6 in it. So in this row, I'd need a 6 here. All right, it just breaks. So anything seen, let's undo to that 6. Anything seen by both of these cells cannot be 6. So these cells, I'll put them in purple. Purple cannot be 6. So obviously these are already not 6. This already couldn't have been 6. So we're going to focus on the cells that are now non-6. And let's see what the possibilities are now. So this could be 1 or 2. Can't be 3, 4, 5. Now it can't be 6. Could be 7. Can't be 8, 9. Over here, this could be 1. Can't be 2. Could be 3. Can't be 4. Could be 5. Can't be 6 anymore. Could be 7. Oh, can't be 7, 8, or 9, actually. And this one could be 1. Can't be 2, 3. Could be 4. Oh, can't be 4. Sorry, can't be 5. Can't be 6 now. Can't be 7, 8, or 9. So this is a naked single 1 now. All right. And that's great because that resolves our grays here for these columns. Because those row ones could go in those columns. We got a sneeze. I'm sorry. Holy moly. I guess I'm allergic to skyscrapers. All right. So those are, we don't need those purple anymore. I'll leave the green so you can see that we end up with skyscraper with at least 1 6 in these 2 cells. In fact, I'll change it to be our 6 color, which is actually orange. All right. What else can we do here? So we got this 1, and that cascaded to these columns. So these columns have 3 left now. What's left here? 2, 7, 8. Yeah, this can't be a 2. Oh no, not 2, 7, 8. I missed this 2 here. 7, 8, 9 is what's left. Okay. Can't really do anything with that yet. What else can we get out of this 1 here? These ones look in, so 1's in 1. Oh, there's a hidden 1, 2 pair in this box now. That's kind of neat. So this is a 1, 2 pair. Ah, and this one can't be a 1. because the one we placed. So that's a 2 and that's a 1. That's a 3 and a 2. That's a 5 and a 3. That's a 7. We get the 8 here. These aren't 8 anymore. This isn't 8, so this is the 8. That ends up a 5. We get the 4 here. We get the 9 and the 5. We get the 7 and the 9. That's not a 4, so that's a 4. What's left here? One of them's going to be 6. In fact, 6 ends up here. So there we go. 6 ended up in one of these two. This is a 7. I think this ended up 6 as well. So 6 ended up in both, which is perfectly fine. That means these are not 6s. So where does 6 go in this column? One of these two, I guess. I'm going to get rid of the orange at this point. Let's just finish this puzzle. So we need a 7 and an 8 here. Okay. We need a 8 and a 9 here. Okay. What do we need in this row? 1, 2, 3, 4. We need 5, 6, 7, and 9. Okay, well that wasn't where I'm supposed to look. How about this box? Oh, I have a 1 corner marked here. Is that true? Yeah, that's true. So that's a 1. And then here we need a 4, 6, 7. This can't be 6 or 7, so that's a 4. Gets rid of that 4, so that places 4 and 6. And then that means that's 6, that's 7. Over here we need a 5 and a 9 that go like that. This can only be 7 now. We get the 9 and the 6 and the 8 and the 9 and the 5 and the 8 and the 7. Good. Okay. This row has 3 left, so let's target that. We need 4, which can only be placed here. What else do we need? 7 and 8. Okay, so that's 8, that's 7. This box, let's play it. We need 2, 3. We need a 1. Okay, so this is a 1, 2 pair. And then we also need 3 and 8. Okay, we know the order of 3 and 8 at least. That places this 3. So this cell is, let's see, the box needs a 2, 3, 4. Okay, this is a 2, 4 pair. Oh, this can't be 4. Okay. So that's 2, that's 4, that's 1, that's 2, that's 9, that's 1. Final digit's a 9, and we're done. All right, so our skyscraper did end up with 6s here. Yeah. Cool. I wonder if that was the skyscraper I was supposed to find. Let me know if there was a different one. I know I was supposed to find a skyscraper. But yeah, so sometimes it just takes looking through where can each digit go until you find something. Let me know if this was telegraphed in a way that I just didn't understand. Clearly it was set up from the start because we had this 6 looking, so in this row, let's start with that green. So if we look at just the givens, right? All of these givens couldn't be, okay, thank you. Every time I clear a color, it's going to tell me I won, which is annoying, but anyway. This can't be a 6 because of this given, and this given, this can't be 6, and this given, this can't be 6. So that was done. And then in this row, if I start those all there, obviously the givens couldn't have been 6, and then this 6 sees this one, this 6 sees, stop it. Okay, start over. This 6 takes out here, 9, 9, and 1. This 6 sees here, and this, actually, yeah, okay, it was here, yeah, and this 6 sees there. So the rest of these couldn't have been 6. So we do get that skyscraper right from the start, and that does look somewhat intentional to me. These rows are pretty full, other than where the 6s see them. So yeah, could use this right away, and then just probably singles from there or very close to it. Cool. Well, so that's the puzzle. Hope you enjoyed it. Oh my gosh, stop telling me I won. And if you did, then why not leave a like, subscribe, and a kind comment below.